So now we are starting with the optics, right? The ray optics is the chapter name. It is a very interesting chapter. Also, it is very important for JEE Mains and JEE Advanced for both, right? At least 2-3 question may come from the ray optics in the JEE Mains, and the JEE Advanced in 1 or 2 question may come, right? So here we will assume we are going to discuss the property of the optics, or the optics is nothing but you can understand the light. So right, we will assume that light is the wave, right? In this chapter we will assume light is wave, right? In the modern physics there will be the chapter photoelectric effect. There the light will be assumed as a particle, but here the light is assumed to be the wave. We will discuss in more detail in the wave optics also, right? So the first topic of the ray optics will be the discussion of the plane mirror, right? What is the plane mirror? You have seen the plane mirror is this is the symbol from the plane mirror, right? For the plane mirror, the reflection we will discuss, right? Plane mirror, and now the reflection. The reflection, the laws of reflection, right? Light rays incident, you may write the first law of reflection. First law of reflection, right? What is the first law of reflection? If this is the mirror, this is the mirror or the incident surface, it is, this is the incident ray, right? And this is the normal to the plane mirror, right? And this is the reflected ray, incident ray, and this is the reflected ray, right? And this is the mirror. This is the symbol of the mirror. So this is the I for incident angle. I is the incident angle, and R is what? The reflecting angle, So according to the first law, the incident angle and the refractive angle are equal, right? This is the first law of reflection. What is the second law of reflection? Second law of reflection, right? What is the second law of reflection? You tell. If you consider this is the right mirror, right? This is the reflecting surface. This is the reflecting surface. This is only the side view. This is the reflecting surface. So according to the second law, listen one thing. Suppose this is the normal. This is the normal to the reflecting surface. This is the incident ray, right? And this is the reflected ray, right? Incident ray, reflected ray. This angle is I, this angle is R. So according to the second law, according to the first law, the angle I and R are always equal. According to first law, so this incident ray, this is the reflected ray, right? And the normal to the incident of the plane, what is it? This is the normal to the incident plane or incident surface. All these are in the same plane. This is the second law of reflection, right? According to this, right? Incident ray, reflected ray, and normal to the incident plane, right? Lie in same plane, right? This is the second law of reflection, right? Copy this. In this case, listen one thing, the angle I and angle R are equal, right? In the special case, you may write first is the normal incidence. Normal incidence mean if this is the plane mirror, right? This is the reflecting surface, right? And it is represented by this symbol. So this is the reflecting surface, mean this is the mirror like this, right? This is the mirror like this. This is the reflecting surface. The normal incidence mean the light rays incident normally. So if this is the incident ray, can you tell me what is the angle I for this? the angle I is nothing but the angle made with the normal, right, by this incident ray. So this is the angle I. If this incident ray become like this, so the angle I become 0. Although it is the normal incidence, the angle I, incident angle, is 0, and therefore according to law of reflection, the angle R will also be equal to 0, right? Therefore if this is the incident ray, so it is reflected in the same direction, in opposite direction, right? So this is the reflected ray, right? This is called the normal incidence, right? Second is the grazing incidence. Grazing incidence. Grazing incidence mean, if suppose this is the reflecting surface, and the normal is this, right? This is the normal to the incident plane. If this is the incident ray like this, if the incident ray is like this, it hit perpendicular to the surface, then the incident angle is 0 and it is called the normal incidence. If its angle is increasing like this and it just is tangent, it just touches the surface like this, so here the angle of incident is equal to what? Say 90 degree, and therefore the angle of reflection is also the 90 degree, and this is called the grazing incidence. Grazing mean it grazes the surface, right? Tangentially it touches the surface, and this is the incident ray and this is the reflected ray. All right, so this is called the grazing incident, right? Copy this. So next topic is the deviation, right? It is very important. Deviation. What is the deviation? It is represented by delta, right? If this is the plane mirror, right? If the light is incident like this is the incident ray, right? This is incident ray, right? If the mirror was not present, right, it should move in this way, it should go in a straight line like this, but when the reflecting surface comes in its path, so what will happen? It deviates its path. It should go in this direction, but it's deviate in this way, right? Suppose the angle of incident is I, this is the R, so the angle R is nothing but equal to I, so this is the angle of deviation. Is it clear or not? This is what it should go, it should move in a straight line, but now it is moving in this direction, so there is a deviation or not, right? There is a deviation. If it is incident ray, this is the reflected ray, fine. So what is the angle of deviation? Angle of deviation delta is equal to what? If it is what? 180 degree, you may write it is I and I. So what is the angle of deviation? Is nothing but 180 degree minus 2i. Is it clear or not? 180 degree minus 2i, and in which sense it is? It is anti-clockwise. Anti-clockwise. This is called the angle of deviation, right? Angle of deviation. Listen one thing, although it is anti-clockwise, sometime it may also be written, right? If this is the incident ray and the reflected ray is like this, so either you can say that 180 degree minus 2i, pi minus 2i is the angle of deviation in anti-clockwise direction, but also the same thing may be written as, listen, if it was the light ray, now it is moving in this direction, right? This is I, this is also I. So what is the angle of deviation? If it was the initial direction, now the direction in clockwise deviated by like this, so this is again the deviation. So either you may write like this, or the deviation also you may say this is what? 180 degree, 180 plus 2 pi, 2i in clockwise direction, right? Pi plus 2i in clockwise direction. So generally sometime you will get the answer in your book pi minus 2 pi, but they will not write the anti-clockwise direction, or in when you will see in some book the answer comes with pi plus 2i, but it is clockwise and anti-clockwise difference, right? Both answer are correct, right? So but it is clockwise, it is anti-clockwise, it is clockwise sense, right? Both are correct. Copy this. For example, I'm giving you one illustration. Suppose this is the mirror, right, and the angle, this is the incident ray, and it is right, it is incident at 10 degree, right. This is the incident ray, right, incident ray. So the reflected ray will make the angle 10 degree also, right. So what is the deviation? Find deviation, find angle of deviation, angle of deviation, right. Listen one thing, it should move in this direction. If plane mirror was not there, it should move in a straight line. Now it is turned, it is deviated by how much? What is the angle of deviation? You may write the angle of deviation is how much? It is 180 degree minus 2i, right, like this. And this is 180 minus 2 into 10. It is 160 degree. And what is the sense? You will sense this is what? This is clockwise sense, right? Or you may write the same angle deviation may be written as, if this is the deviation in clockwise sense, in anti-clockwise sense, it was the initial direction. Now it is moving or the traveling in this direction. So what is the another deviation? This is the delta 2. And how much it is? This is 180 degree plus 20 degree, or delta 2 is 180 plus 2i is equal to what? 180 plus 2 into 10 is equal to 200 degree, right, in anti-clockwise sense. So there will be the deviation 160 degree clockwise or anti-clockwise 200. When you will add both deviation, then you will get definitely the 360 degree. 160 plus 200 is equal to 360. So both answer for the deviation are correct, right? Copy this. So now we will discuss the effect of rotation, right, of incident ray, Listen one thing, suppose effect of rotation of incident ray on reflecting ray, right. Listen, if this is the mirror, is it clear, and this is the torch, and from the torch the light is coming in this way, is it clear? This is the incident ray and it is reflected by the same angle. If this is I, this is I. Is it clear or not, you tell? Now if this torch, suppose this is the torch, this is the point about which the torch is rotating in this direction, suppose, right, it is rotating like this. So here the torch, when the torch reaches at this point, if this is rotated, the torch is rotated by theta angle in anti-clockwise sense. Now this is the incident ray, so therefore this is the reflected ray. So the reflected ray is also rotated by the same angle but in opposite sense. So this is the first, for the first, the second ray, right. For the third incident ray, this is the fourth reflected ray. Is it clear or not? So therefore if mirror is fixed, and incident ray is rotated, by angle theta, then the reflected ray is rotated, in opposite sense, by same angle theta. You understand or not? If it is rotated by 10 degree in anti-clockwise direction, the reflected ray is rotated by the 10 degree in the opposite sense, in clockwise sense, right? Copy this. Now if direction of the incident ray is fixed, incident ray is fixed, right, incident ray is fixed, and mirror is rotated. Mirror is rotated. Is it clear or not? Mirror is rotated. For example, if it was the initial direction of the mirror, right? This is the point, and this, the mirror can be rotated about this axis, right? Suppose this is the mirror, right? And about this axis, it can rotate like this. It can rotate. Is it clear? So initially, suppose the light ray is incident. Normally, suppose, for example, what is the incident angle here? Say the incident angle is 0 degree. Normally, student think initially it is 90 degree. So what is the R value? Say 0. But this is the incident, this is the direction of the incident ray is fixed. Now if you rotate this angle, rotate this mirror by angle theta like this. Is it clear or not? It is rotated by theta. It is rotated by theta in this way. So if it is rotated by angle theta over here, and the normal, initially the normal is in this direction, so the normal is also rotated by angle theta. This is the normal. Initially the normal is in this direction. Now the normal is also rotated by theta. You understand or not? This is the normal. So if the incident light does not change its direction, it is the incident ray, right? This is the incident ray, and the reflected ray are in the same direction. Here it is the incident ray. So where will be the reflected ray now? Where will be the reflected ray? The reflected ray makes, this is the angle of incident now. The angle of rotation of the mirror become the angle of incident for this incident ray, and this is the theta, which is R. So this is the reflected ray. Is it clear or not? You tell. Reflected ray. So you tell. Here the reflected ray was going in this direction. Now after rotating this mirror by theta, the reflected ray does not go in the same direction. Rather, the reflected ray is rotated by this. So what is that? This is the rotation of the reflected ray. By what angle the reflected ray is rotated? Tell me. By what angle the reflected ray is rotated? The theta plus theta. Initially the reflected ray was in this direction. Now by rotating this mirror, the incident ray rotated by angle 2 theta, right, in the same direction. If it is rotating, the mirror is rotating in anti-clockwise sense, the reflected ray is also rotating in same sense, right, by angle 2 theta, right. If direction and is fixed, the mirror is rotated by angle theta, then reflected ray is rotated by angle 2 theta in same orientation, or in same sense, same orientation, right, like this. You understand or not? If it is rotating clockwise and it is rotated, the mirror is rotated anti-clockwise, the reflected ray is also rotated anti-clockwise, but by double of the angle of the rotation, right? Copy this. Okay, for example, if it is the plane mirror, right, and this is the incident ray, right. If incident ray is rotated anti-clockwise direction by 10 degree, right, and also and this mirror is rotated by 4 degree, right, in clockwise direction, right. If incident ray is rotated, it is rotated by 10 degree in 10 degree anti-clockwise sense, and mirror is rotated by 4 degree, in clockwise sense. You understand? Find the angle by which reflected ray is rotated. Reflected ray is rotated. You understand or not? So how to solve? Listen one thing. The effect of the incident ray, rotation of the incident ray, right? If it is rotating in is anti-clockwise, right? It is what? Anti-clockwise. It is what? Clockwise. So for the effect of the rotation of incident ray is just opposite. So the total angle of rotation of for reflected ray, reflected ray is equal to what? 10 degree in clockwise sense, because just opposite and equal, and it is 4 degree, right? 4 degree. This is the mirror rotate is 4 degree in clockwise sense. So the effect of mirror will be the 2 times in the same direction. So 2 into 4, right, in same direction. You understand or not? So it is 10 degree clockwise. If you assume the clockwise is to be the positive, right? If you take this direction, is positive, right? So the 10 degree is positive, and this is the 8. So how much it is? 18 degree clockwise, right? 18 degree clockwise. Understood? So if it was the incident ray, it is clockwise being like this. So if it was the initial first ray, now it is rotating by, I'm making the figure here. What does it mean? It means if initially incident ray and initially it was the reflected ray, if it is rotated by 10 degree in anti-clockwise sense, and it is rotated by 4 degree in clockwise sense. So if it was the first incident ray, reflected ray, then it is rotating clockwise. This is the second reflected ray, and the angle of rotation is 18 degree clockwise, right? Copy this. Now the image formation by mirror, right? Image formation by mirror, by plane mirror, sorry. It is the plane mirror we are discussing. After this, the spherical mirror we will discuss, although the plane mirror is not included in the syllabus, right? In the NCERT it is not given. In the NCERT, the spherical mirror, from the spherical mirror is started, because the plane mirror we have taught in class 9th and 10th. That's why it is not given. But the information or the basic concept is very necessary to solve these type of the question, right? So the image formation by plane mirror, first for point object. What is the point object? Suppose this is the mirror. If the source of light is placed in front of mirror, right? So, and the light rays are emerging from its mirror. It's the source of light. Suppose this is the bulb, and the light ray are emerging from it. So its image is formed behind the mirror. And how to form the image? To get the image, only the minimum two rays are required. Suppose this, I will take this is the one ray. So when it is reflected from here, right, if this angle is I, this angle must be I, right? So this is the reflected ray. You can take one more light ray like this, right? This is I, this is also I. So when this is the reflected ray, right, are you getting? So when they are extended behind the mirror, they will appear to meet a point. Suppose this is the source of light, you can say this is the object, so this is the image, right? For example, if you are standing in front of mirror, you will see your image behind the mirror, and that image is virtual image. Is it clear or not? And this object is the real object, and I am talking about first the point object. Point means the source of light. Is it clear or not? For if the source is kept in front of the mirror, then it is called the real object, and its virtual image is formed behind the mirror by doing this ray diagram, right? Listen, one more thing, not only these two rays, rather the image may be formed in this way. Suppose this is the object, the one light ray is incident like this, so when it is extended behind this, is it clear or not? Right, and the another light ray you can take in this way, right? There is another way to make the image. So this is also the correct, right, ray diagram to find the image. Is it clear or not? So at least you have to take the two rays, right? It is incident over here I, and this is I. This is suppose, right, I dash, and this is I dash. So when these two reflected ray, any two reflected ray, when they are extended, right, behind the mirror, they will appear to meet at a point, and this is called the virtual image. Is it clear? All, or you can use these two rays to draw the image, right? One more figure, because it is very necessary in any book. If it is clear, then it will be beneficial for you. If you take one incident ray, after reflection it will be extended over here. If you take this ray, this is the incident ray, it is the normal incident, and therefore this is the reflected ray. Incident normally, refracted normally, like this. So when this is extend behind the mirror, so the image is formed at this point. So in this way also you can draw the image. Is it clear or not? One more thing, if this angle is I, this angle is I, this angle is I, this is the isosceles triangle, right? So if you assume this is to be the origin, right, and you assume this is to be the x, so the distance of the image from the origin, right, you will assume this is the origin, and this is the distance of the object from the origin, right? Although if you write this is the vector, the image distance vector is just opposite to the object distance vector, right? In magnitude, if this is the distance xi, this is the distance x2, if you take the magnitude, the magnitude are also equal. Is it clear? So this distance behind the mirror and this distance in front of the mirror of the object and image, both are present at equal distance, right? This distance are equal. Is it clear or not? Right, copy this first. So this object, when the point source of light is placed in front of mirror, it is called the real object, and this image is virtual image. The object is real if you can touch this source of light, then it is called the real. And if you cannot touch the image by your hand, right, it is not, it is virtual. Or you can also say, if the image is obtained on the screen, then it is called the real image. If it is obtained on the screen, then it is called the real image, otherwise it is virtual image, right? For example, this is the case of the real object and the virtual image. Suppose the second case you can consider, if this is the mirror, right, and the light ray is incident like this, light ray is incident on this, right, like this, right? So they will appear to meet at this point, right? And therefore after reflection from the light, the reflected light ray are meeting at this point. So this is called the virtual object, and after reflection from the mirror, the light rays are meeting at this point, and this point in front of the mirror can be touched by your hand, or this image can be obtained on the screen. Therefore this is called the real image, right? So the real image is always formed in front of the mirror, and the virtual image is always formed behind the mirror, right? The like this, right? So this is the real image and the virtual object, right? Copy this. Now we will try to understand the concept of the field of view. Field of view. Field of the view is the region in which if your eye is present, you can see the image. It is the reason. It is the reason in which I can see the image. Right? I can see the image. Right? This is the region. Let me explain you first. Right? For this case, right, for this case, suppose this is the mirror, this is the mirror AB, and if the object, the source of light of object is placed over here, is it clear or not? So can you make the image formation? Yes. Listen one thing, to make the image, it is not necessary that the object must be in front of the mirror, right? It may be far away from the mirror in this way. Although the mirror is not in front of this object, the image can be formed, right? How? You just extend this line, and this is the one incident ray. You are taking only the one light ray, right? After reflection, it move in this direction. Take one more light ray. After reflection, it move in this direction. So if you extend, right, this is the light ray. Give me 1 minute, like this, right, like this. Is it clear or not? So this is the image. So although the mirror is present over here, its image is formed, right, its image is formed behind the mirror is the same distance. If this is the distance x, this must be the distance x. The property of the image and object is that the line joining object and image must be perpendicular to this, perpendicular to the mirror. Is it clear or not? This is also one question is asked. The line joining object and eye cut perpendicularly to the mirror, or the line passing through the mirror like this. Is it clear or not? Now what is the field of view? If this is the torch, suppose this is the torch, right, and this is the mirror. If this is the torch and the mirror in front of this, you can see the image of this pen or this torch in the mirror, right, behind the mirror. But if the mirror is over there and the pen is over there, are you getting or not? And you are seeing from this side, so the mirror is above the pen. It does not mean the image is not forming, as in this case. The image of the pen is formed by this mirror, but you cannot see the image of the mirror if you are standing here. So where you have to put your eye to see the image, this is the field of view. Is it clear or not? If your eye is present in this region, cannot see the image, cannot see. But if your eye is present in this region, this is the field of view, can see the image, can see the image. Is it clear or not? So this region after which the reflection, the light rays is going in this direction, right, you can assume this is the reason, right? So this is the field of view, right? This is the mirror, the light ray from the starting, from the end you are taking, and this is the field of view where the image can be seen. If this is the object and you are putting your eyes here and there, right, near this, you cannot see because your eye is not present in the field of view. So field of the view is the region in which the eye can see the image. Is it clear or not? Right, copy this. So the image formation we are discussing, we have discussed the image formation for the point object. Now for the extended object. Extended object. What is the extended object? Suppose this is the mirror, right? In front of this mirror, the object AB is placed over here. Is it clear or not? So how to make the, how to draw the ray diagram for this object AB? So in front of this, right, behind the mirror, the image is formed A. This is the A dash, and in behind the mirror at the same distance it is the B dash. So if you join this, this is the virtual image A dash B dash. That's it. How to make this image? For the A, if you take the one ray like this, it is reflected over here. The another one more ray you can take, right, like this. So this is the image formation for the A dash. In the same way, right, for the B image formation you can take, this is the one incident ray normally, right? So it is reflected. So if you if you extend this behind, it will meet over here, and one more ray you can take like this on this mirror. So when it is reflected, so it is the formation, right? So or you can take, this is the one ray, right? It looks good, right? So this is the image formation of B for the B dash, A for the A dash. Any other point present on this extended object may be, right? Draw the ray diagram in this way. Is it clear or not, you tell? Right. So this is the image formation for extended object in this way. Listen one thing. For example, if the in front of the mirror the F is placed like this, is it clear or not? So if this is A, this is B, this point is C, this point is D, and this point is E. Are you getting? It is better to do a little big, right? This is an object F. Fine. So its image is formed like this, right? I'm making the dark like this. Is it clear or not? Like this, right? If A, this is the A dash. If B, this is the B dash. This C, this is the C dash. This point D, this point is D dash. If this point is E, this point is E dash, right? This is called the lateral inversion. Lateral inversion. All right. So any object, if it is placed in front of mirror, its inverted image is shown in the figure, in the behind the mirror. Is it clear or not? Right. Copy this. The explanation is that when you see the ambulance, right? Okay, the lateral inversion, the application of this lateral inversion you have seen many times, right? When the ambulance, you have seen the lateral inversion is printed as an ambulance in front of the ambulance car. You understand why? Because when it is seen in the mirror, its lateral inversion, which is the correct way, correct order of the words, is shown by the driver. Is it clear or not? So this is the application of the lateral inversion by the mirror, right? Copy this. So read this question. In this question, a light ray is to travel from point A to point B as shown in figure. Suppose this is the mirror, right? This is the point A and this is the point B over here. This is at 4 centimeter and this is at 12 centimeter. So the light ray has to travel after the reflection. Although light ray can go directly here, but they are not asking like this. After hitting, where should it be hit? Right, this distance is given, the length of this mirror is given as like 12 centimeter. After reflection, it must meet to the point B, right? So which distance it should be meet, right? Suppose this distance is X. From this line, suppose this is the A, right? This is the C and this is the D and this is the point P. So at point P, the light ray should be incident so that after reflection, it meet to the B. So we have to find this distance X. If this total distance 12 centimeter given in the question, so if it is X, then it is 12 minus X. Also, the property we are going to apply, this angle of incident and the reflection angle are same. If this angle is I, it must be I. If this is I, it must be I. Right. In this triangle, tan I is what? Tan I is perpendicular upon base. In this case, the tan I is equal to what? Perpendicular upon base. Is it clear or not, you tell? right? So tan I both are equal. X by 4 is equal to 12 minus x upon 12, right? And 3x is equal to 12 minus x, 4x is equal to 12, and x is equal to what? Say 3 centimeter. Is it clear or not? So this distance is the 3 centimeter from point E C. It should be incident so that it may meet to the point B, right? Copy this. So read this question. In this question, you have to find the minimum height of the mirror so that you can see the complete image, right, by of yourself. How? Suppose this is the mirror, the big mirror is over there, and in front of this the person is right like this. It is standing like this, right? Suppose this is the eye, this is the head, and this is the foot of the person. Is it clear or not? So he want to see his complete image, full image in front of mirror. So minimum how much height of the mirror is required? It's just half of the height of the person. This is the first thing, right? Suppose the height of the person is assumed to be the h, right? So how to see the full image? Listen one thing. To see from the foot to head, if I am standing over here, I should see my head to the foot. So if the foot is seen by eye, right, foot is seen by eye, right, so it should be like this. This is the light ray incident over here, and it should meet to the eye. Is it clear or not? It should meet to the eye in this way. Fine. If this angle is suppose the theta, it must be the theta. All right. And therefore, listen one thing. If you assume this distance is to be the x1, so by the symmetry, this distance is also equal to the x1. Is it clear or not? Now, to see this head, right, the light ray incident on the mirror, and it should reflect it back to its right eye. Is it clear or not? Right. So if this angle is assumed to be the alpha, this angle is alpha. Is it clear or not, you tell? So look at the figure. If this distance is x2 and this distance must be x2, because the triangle is similar triangle, right? This angle is alpha, like this. You understand this thing or not, you tell? Right. So this is the way. So listen one thing. If this mirror is not required, this mirror is not required. Only from here, and also this mirror is not required. Only this mirror is sufficient to see his full image. For example, this point he want to see, so it is incident, it is reflected and incident to the eye. Is it clear or not? If he is able to see the light ray originating from the foot, then all other ray he is able to see. So therefore this part of the mirror is not required to see the image. In the same way, he is able to the light ray originating from the from its head, from his head. So all other light, all other point may be seen by the eye. So no need to write, no need this part of the mirror. You understand or not? So only this is the important part. This is only the part of the mirror which is required to see his full image. And what is this height? X1 plus x2. Therefore, required length of mirror is x1 plus x2. Is it clear or not? So this is the required mirror height from here to here. It is not required, it is also not required, right? But x2 plus x2, this is 2x2. x1 plus x1, this is 2x1. So 2x1 plus 2x2 is nothing but the total height of the person. So x1 plus x2 is nothing but h by 2. So the length of the mirror required is x1 plus x2 is nothing but h by 2. That is the half of the height of the person required, right? The length of the mirror is required. You understand this question? Varsha, please tell. right? Copy this. Read this question. Write a point object O can move along the vertical line AB as shown in figure. What is the figure? This is the mirror, right? The length of the mirror assumed to be the A, and when image of the object is first visible to D, this is the point D, right? Your eye is present over here at distance L by 2 distance, and behind this L by 2 distance the line AB is present, right? Like this, and the object O is released. The object O is released from the point A when it is first seen by the D. Listen one thing. When the object is first, if the object is moving in this way, right, moving in this way, when it will be seen, you tell me. This is your eye. When it will be seen. Now, if the object is at this point, it is over here, the light is like this, so will it seen? No, it cannot be seen. When it comes at this point such that it will start, this is the A, you may write this is the A, right? This is the point A, and the light ray reaches to the point D, point on your eyes after reflection, right? So it start seen over here. Is it clear or not? Like this angle is I, this angle is I. Until what point the object will be seen? If this is the object O, it is released from rest U is equal to 0 and it is falling under gravity like this. So up to this point, right, up to this point the object will be seen. For example, if the object is over here, it is reflected and reaching to the eye. If object is here, reflecting and reaching to the eye. But if the object is over here above this point, it is reflecting and the reflected rays like this. You understand or not, you tell? It will not be seen. So when it comes in the range, the field of view, then the object image can be seen. Is it clear or not? So listen one thing. If this is I, this is I, this distance is supposed to be the L, right? This is also equal to the I, right? And this distance is also equal to the I. Getting or not, you tell? So in this triangle, if I assume this is to be the X, right, this distance is to be the L by 2, right? By symmetry, if this is L by 2, this is also L by 2. Is it clear or not? Because it is in mid of the mirror. This is L by 2. So this distance is what? Say L by 2. And this distance you may assume to be the X because this angle is I. First of all, this figure must you understand, right? In this figure, in this triangle, tan I. What is the tan I? Say perpendicular upon base, L by 2 upon L by 2. It is equal to 1. In this triangle, tan I is equal to, this distance is X, tan I. In this triangle, tan I is equal to what? Perpendicular upon X. Are you getting or not? So tan I is equal to 1 is equal to X upon L. So what is the value of X? Say L, right? Yes. Now this distance is assumed to be the L. Therefore, by symmetry, this distance is assumed to be the L. So if the point object is released from rest under gravity, so how much distance it has to cover, right, till it is seen by this I present on the D? The height is 3L. Fine. So what will you apply? S is equal to ut plus half at square, half gt square, u is 0. So the time is what? Root 2h upon g. And what is the height? It has to fall. It is 3L. So therefore, root 6L upon g is the time. Root 6L upon g is the time. You understand? So till this time, the object will start from here till this time it would be seen by this I present on the D. Right? Copy this. Read this question. In this question, a plane mirror make an angle 30 degree with the horizontal. This is the horizontal. Now the plane, this is the mirror. With the horizontal, the angle is 30 degree. All right. And the light is incident normally. Is it clear or not, you tell? This is the 30 degree. All right, like this. Okay, so you tell, if the plane mirror is like this, it was the normal. If it is rotated by angle 30 degree, right? So the normal is also rotated by 30 degree. You understand or not? This is the normal. So now here, if the plane mirror is horizontal, the incident ray is vertical. What is the incident angle? Say 0. So the reflected ray will move in this direction. But if it is the incident ray, right? And this is the incident ray, and this is the normal, like this. So now the incident angle is 30 degree. So the reflected angle is also equal to the 30 degree. Is it clear or not? Like this. And if this angle is 30 degree, this angle is 30 degree, this angle is 30 degree with the horizontal, right? This is the reflected ray. So this is the incident ray, this is the mirror, this is the horizontal direction, this is the reflected ray, right? This is normal. So reflected ray, the angle between the mirror and the reflected ray. Okay, so this is the mirror and this is the reflected ray. So what is the angle? So angle, therefore the angle between reflected ray and mirror is what? Is 60 degree. So the C option is the correct option, right? Copy this.